my name is Pushkar, and today I'll be presenting my project titled Personalized Movie Recommendation Multiple Strategies in Action. This falls under the track of Content Recommendation System. In this project, I've tried to make recommendation engine more accessible, not just as a black box we see, but as a playground where we can visualize different strategies, compare their outcomes side by side, and see how they evolve from a simple baseline to advanced models. So now let's talk about problem we are trying to solve. There's a very limited customization. Recommendation engine have been around for a while, as you all know, but they often are a black box to us. Whether it's popularity based, genre based, or similarity based, there's very little room for learners to understand and customize them. Recommendations aren't one size fit all. They evolve from simple baseline to collaborative filtering to neural based models like Two Tower. Each has its own pros and cons, and I wanted to showcase these nuances side by side. Lastly, is the barrier to experimentation, wherein many people believe you need a powerful machine to train and demo such system. Our project shows that just by using Google Colab and having a right intent, you can train the models and even build a full working dashboard exposed to web via tunneling. This means anyone can learn, experiment, and deploy quickly. The key goal of this project was to create a hybrid recommendation system with multiple strategies. So we started with the baseline recommended using popularity and genre-based recommendation, moved to SVD, and which is a collaborative phase filtering, and finally the two-tower neural network recommender, which is an advanced recommendation system. And finally, we build a Streamlit dashboard to showcase everything. It ties everything together. So the outcome is not just a working recommender, but also a learning playground, a place where a beginner can see how different approaches behave, experiment with the inputs, and visualize the cold start and personalization challenge. So coming to the methodology, we pick MovieLens 100K, which has user ratings, and movie metadata. We use tools and like Python, Pandas, NumPy, Learn, TensorFlow. We use Streamlit to build our dashboard, Google Colab to run, build, train, and deploy everything. And Cloudflare Tunnel is the one that would help us tunnel the output from Google Colab into a Streamlit dashboard. The approach we would use were compare baseline, then have a SVD and two-tower model. We focus on the temporal split validation for realism and deploy via this tunnel methodology that we talked about.
Now see the working demo of our data set. So I have created a Google Colab sheet wherein I have incorporated all the code pieces. The data sets that is needed is there in the Google Drive. So if you see the data set, we have user data, user genre, user ratings, items has the movie data, and user has the user information. So we started with loading the data sets. So if you see, we use data frames. So pandas.read.csv first read everything and transform into form of data frames. Data frames would give us a tabular structure around this data. Then we loaded the rating data set, we loaded the movie data set, prepared data frames around it. Now we have loaded all the files that are there. Next, we started merging the data set. So the composite key between all the data set is movie IDs. So we tried to merge the data sets based on the movie ID. So we prepared a merge data frame that would be merging the ratings and the movie data frame. Rating would be comprising of user ID and rating details, and movies would be movie ID and movie details like genres, metadata of the movies. So if you see the user ID merged with movie ID has a rating, has a timestamp, then it comes the title of the movie, release date, and all the metadata you can see around the movie, what type of movie it was, and all the details are here. Next step that is very essential for any before we move to any modeling technique would be the data cleanup. So we did the standard cleanup of the data. So we checked if there are any NANs present or not. Then we moved to check like if the rating should be within the set limit of 1 to 5, if there are any missing titles or not, right? Then we move, then we drop like any sort of data after data cleanup, we drop the missing indexes and we re-index everything. Post that, we sorted the data set. So we prepared two ratings DF sorted and average time gap. So this would be used to check if there are any robotic sort of entries. So if they in a very fraction of seconds there are thousands of entries, so we would be trying to remove those entries to make the data set very real life. It shouldn't be any auto-generated or machine-generated ratings. Now next step would be the temporal split. So we'll split the data into train, validation, and test in the ratio of 80-10-10. So 80% would be the training data on which we would train. Then 10% would be validation data, and finally 10% would be the test data. Okay. So once we have created everything, we'll move to creation of positive and negative sample. That would help us to prevent any leakage or scenarios wherein the model might already know the data of future. So we'll prepare certain positive and negative scenarios based on the certain threshold that we have kept as 4. So anything that is more than 4, we have added as a positive rating. And then out of all the negative rating, we have randomly picked few of the samples as negative. So we do the np.random choice to select those type of data. And finally, we applied it to our train balance test samples. Okay. So after all the cleanup, all the having all the data splitted, we move to baseline modeling. What this would give us, this would give us an insight into the data. What is the most popular? What is the highest rated movie? So we try to get certain insights from this data set. So this is the popular movie. If you see, right, we displayed the popular movie. So these are the popular movies based on the average rating and the number of ratings it got. It shouldn't be there's one rating and it got 5-star rated and that should come on top. No, there should be a good number of ratings and that rating should be quantifiable number to come up in this list, right? So I tried to see some other insights also, like top movie per genre. So build a code around it, and if you see, these are the movies that came up as like if I saw that what is the top movie in the horror genre, so this came up as a top choices. So after the baseline and seeing some insights around the data, we move toward the collaborative filtering, which using the SVD, singular value decomposition. So SVD is a matrix factorization technique. We start with user movie rating matrix. That's very sparse. So if you see the rating matrix has lots of 000 and somewhere it would be 1. So it's a multi-hot vector for us. So it's very sparse. So SVD decomposes it into latent factors, essentially hidden features that captures user preferences and movie characteristics. So first we prepared the matrix. So this is a prep work. Then we used truncated SVD from a scale-learn.decomposition. And based on that, we prepared this SVD model. So yeah, so this is my predicted rating. So predicting rating should be always between 0.5 to 5. So we just are doing the clipping around it. So so that our predicted rating should look very realistic. Okay, so let's move toward the twin tower model. We saw how SVD worked. Now the twin tower model we would work. This would be an advanced neural network based recommender. So to begin with, we'll start the genre encoding, that is a multi-hot encoding around the data set. So in this step, I'm preparing the movie data for the item tower. Each movie belongs to multiple genres like action, adventure, comedy. So we use a multi-hot encoding, which we took from scale under preprocessing multi-level binarizer. And basically, what we are trying to do is we are just doing creating a row of zeros and one to capture which genre apply to each movie. So if a movie is comedy plus romance, the columns for comedy and romance are set to one, and other all columns would be zero. This way, model doesn't just see the movie ID; it also understands the genre characteristics. So, okay. So the reindex IDs. So next step, we map user IDs and movie IDs to simple integer indices. This is important because models don't work on the IDs. They need indexes to fetch embeddings from the lookups. So this step is needed therein. We created user index and item index that would be used to pick individual records from the user and item towers. Now we build the actual two tower model. So the user tower represents each user, capturing their taste and pattern, and the item tower that would learns vector representation of each movie, combining both its ID and its genre vector. So from the code, if we see, what we did is we used TensorFlow.keras layers and TensorFlow flow. We inputted the keras. The keras has all the models. So keras.model we pass in the user input, user vector, and for item tower we pass in the genre and the movie details. So here are the item input and the genre that is being prepared and being passed to the keras.model. So if you see, use input and genre has been passed here as an input, and output is the item vector that we are expecting. Once both the tower are ready, we combine them using the dot product and sigmoid. So this gives us a probability between 0 and 1, basically how likely a user is to interact with a movie. After this step, we compile and train. So basically, we are using the binary cross entropy loss. Uh, like, if I like we train on BC loss because this is a binary classification task. One if a zero watched, one if a user watched or rated a movie, and zero if not. Okay, so we are using Streamlit to build our dashboard. So here I build a Streamlit app, and that brings together everything we developed in this project. So the app is divided to three sections. The first is the baseline, which shows the most popular movie and the highest rated movies. So this sets the stage by showing what a very simple recommendation strategies look like. Right? So the from slider we can select how many movies that we want, and based on that it would provide you the popular movies. The second section is the cold start genre by recommended by genre. So here I can pick a genre, for example, action, and instantly get a movie suggestion. So what's interesting is that we show results side by side. On one side, the SVD collaborative filtering approach, and on the other, the two-tower neural network. This makes it easy to compare how the two models handle the same input. The third section is movie to movie similarity, and this is more interactive part. If I enter a movie like Toy Story 1995, the system finds and displays the closest movie based on the embeddings in latent space. This is very intuitive of for users because it mimics the because you watched experience we often see in many platforms. All of this runs in one place. So instead of flipping through notebooks or raw code, I can interact with the models, change the input, and see recommendation update instantly. So overall, this app act as a live demo of how different recommendation strategies perform and make it the whole project more accessible and engaging.